Here in this video, we are solving two problems based on nuclei and radioactivity. Both are almost belongs to the same concept. Let me solve the first question. The first question says, the radioactive material A has a decay constant 8 lambda and B has a decay constant B. Initially, they have the same number of nuclei. After what time the ratio of number of nuclei of material B to A will be 1 by E. See, what I am saying is, there are two radioactive materials. They disintegrate and the relation between them equal to, how do they disintegrate is lambda T, where N is the number of nucleons at a given instant at the time after some time T. N0 is the initial number of nucleons. Lambda is a constant called decay constant. I have derived this relation in the chapter radioactivity nuclei. Please see, refer that list if required if you don't know this formula. So N by N0 can be written like E by lambda T. Now he is saying that there are two cases where when the decay constant is 8 lambda, I can write N1 as N0 e power minus 8 lambda into T, because he said initial decay constant is 8 lambda. In the second case of B, N2 equal to N0 is same because it is given that initially they have the same number of nuclei, both of them, minus lambda into T, because in the second case decay constant is given like lambda. You divide these two equations, then what happens? N1 by N2 equal to e power minus 8 lambda T by e power minus lambda T, because this N0s will get cancelled. But this N1 by N2 is the ratio of number of, after what time the ratio of nucleons of material B to A is 1 by A, mean A 1 by E. That means he mean to say N2 by N1 is, let us just reverse this, e power minus 8 lambda T, you get to the top, it becomes plus 8 lambda into T. So what happens then? N2 by N1 equal to e power minus 7 lambda into T. That N2 by N1 ratio of B to A is 1 by E as per the problem. That implies 1 by E equal to e power minus 7 lambda into T. This can be written like e power minus 1. This is e power minus 7 lambda into T. As the bases are equal, powers can be equated. Minus 1 equal to minus 7 lambda into T. Minus and minus also will cancel. So T is 1 by 7 lambda. That means after a time of 1 by 7 lambda, this will happen that the ratio of their nucleons becomes 1 by E. That's how we have to solve that problem. Let's have a look at the second question that is there. The half-life of a radioactive substance is 30 minutes. It was given that half-life T is 30 minutes. The time in minutes, your answer is also in minutes, so I need not make any conversion. Taken between 40% decay to 85% decay is. So the first thing that you need to understand is 40% decay means 60% is present. Remaining 40% has gone into a decay state. So taking that into consideration, you shall know the relation between them as the same. If you extend this relation further, like I have written here, this can be further written like N by N0 can be written like 1 by 2 power of N, where, let me write the terms, N0 is initial number of nucleons before the beginning of the journey, N is number of nucleons present, be careful, N is number of the nucleons present after the given time T, and this n, small n, is actually small t by capital T. Small t is the time after which you are trying to calculate. Capital T is the half-life period. That's a basic understanding. Once you know that basic understanding, I can use this formula. In case 1, 40% decayed means number of the nucleons present, n, this is number of nucleons present, is 60%. That is 60% means 60 by 100. That is n by n0 equal to 1 by 2 power of n. N is small t by capital T. Let me call this small t as T1. In the second case, 85% got decayed. That means remaining is only 15%. That is 15 by 100 of n naught is 1 by 2. It takes some different time for that to happen, but the half-life period is same. So this becomes what? Let's divide these two equations. If we call it like 1 and if we call it like 2, make 1 by 2. What it gives? 60 by 100 means 0.6 by n0. This is 0.15 by n0 equal to 1 by 2 power of, so this in the denominator will go to the numerator, then it becomes T1 minus T2 by T. n0 will cancel. 0.15 is 4 times of 0.6. So what is remaining is 4 equal to 1 by 2 power of T1 minus T2 by T. So what happens is, this becomes 4 can be written like 2 square. This can be written like 2 power of minus T1 minus T2 by T. As the bases are equal, as I told you, we can equate the powers. Let us just equate the powers. What happens then is 2 here power, here it is minus T1 minus T2 by T, or else I can write 2 as T2 minus T1 by half-life. You want the time difference between them. The time in minutes taken between 40 to 60, 40 to 85% decay is T2 minus T1. Take this half-life period to the other side. It becomes 2 into half-life period. But half-life period is given for 30 minutes. 2 into 30 minutes. So the answer will become 60 minutes. That's how we solve this problem. Right? Thank you for watching.